Part 2 of dealing with domain and range would be they give me a word problem, and specifically they tell me to use this word problem to plot the data and fill in their answer choices. So they tell me a candle is 6 inches high and it burns at a rate of 1 inch every 2 hours for 5 hours. Notice they tell me to use interval notation for domain and range, so I don't have to do all three this time. So they ask me the candle's burning rate. Burning rate is another word for slope. How quickly does it work? So that's y change over the x change. Well, my y-axis is height, so it says it loses 1 inch every x is time, 2 hours. So my slope is 1/2, but it also needs to be negative because it's burns. That means the candle's getting shorter, so I'm losing height, which makes sense. I start with a candle, I burn it, it's going to continue to lose height. The candle's height in inches at any time is modeled by, they want an equation. Well, we started at a height of 6 inches. The candle starts 6 inches when no time has passed. So we do 6 inches minus the 1/2 x, which is my burning rate. So that means I go down 1 and right 2. Makes sense. At 2 hours, it's lost an inch. That's what they said, 1 inch every 2 hours. So at 4 hours, I should be at a height of 4. And at 6 hours, I should be at a height of 3. Notice they said that I'm only allowed to do this for 5 hours. So actually, I want to take that point away because I stop right here at 5. If I go down 1 and right 2, that's too far. So I'm supposed to stop right there. That's important. Since the candle burns for 5 hours, the domain, these are the x values, are restricted. I'm allowed to go from 0 time, and I just drew my line, to 5 hours. The range for that part, the lowest y value that I see is, the problem is if you go down 1, right 2, you're too far over. And so at 5, if I plug that in, let's do that really quick. I need to plug in hour 5 to find out what that point would be. So that's 6 minus 1/2 of 5 is what we're doing. 1/2 times 5 is 2.5. So we're doing 6 minus 2.5. 6 minus 2.5 is 3.5. So your y value, this is x, so y would equal 3.5. So at 5, I'm at 3.5. I'm right there. And I have to figure that out because I had to stop at 5, so I have to figure out the y value. So my range is from 3.5. That's where I started. And when I stop is at 6, and I'm equal at both places. Now there are questions on the next page that we're not going to worry about, but we're going to do it one more word problem, and then you can go work on your assignment. We're going to look at this one. While standing on a moving walkway at an airport, you are carried 25 feet every 15 seconds for a total of 1 minute. This is where I have to stop. Notice that your time on your table, on your graph, is in seconds. 1 minute is 60 seconds. So this is where my graph needs to stop, because it said 1 minute. Write a function rule and determine your domain and range, and they want me to use set notation again. So first of all, I'm standing on a walkway. I have moved nowhere when no time has passed. Obviously, no time can pass and I haven't moved anywhere. You're carried forward 25 feet every 15 seconds. Let's figure out our slope. This is the change in y over the change in x. The y change is distance, so that's 25 feet over time, which is 15 seconds. Now, that fraction can obviously be reduced. 25 divided by 15. You're never allowed to use a decimal, so we've got 5/3. So my slope is 5/3. My y-intercept is 0, so my function rule is 5/3 x plus 0. I don't have to show the plus 0 if I don't want to. So at 0, I'm going to go up 5. That's up 10, so that's too many. Up 5 is halfway, and to the right 3. Well, if that's 20, this is 10. So here's my suggestion. Go into your calculator, type in 5 divided by 3x, and go to the table. 0, 0 is right there. Obviously, x is time. We don't have negative time, so you can't use that point. So at 3, I'm at 5, but that's a problem because I don't have 3 on the graph. So let's go all the way to 10. Nope, I don't like that point. I don't like 10. 12 seconds, so it's kind of right here, is at 20. So we're going to be right about there. And then, let's see, at 15 seconds, so that's exactly in half. There's 10, there's 20, so 15's right in half. You're at 25. At 18 seconds, let's not use that one. 21 seconds, you're going to be at 35. And the important part is you got to get all the way to 60. So here's how you do that. Second table set. Let's make x 60. You're at 100. So 60, we're here. And I know I start here. And I may connect all of these points. So everything along that line will fit. Now then, I have written the function rule. There it is. I need to determine the domain. And they asked me to use set. And set notation is the x such that. X such that. We start on the left for x and move to the right. I'm going from 0, and I'm allowed to be equal to 0 time. And I'm allowed to equal 60 to 1 minute. But specifically here, they don't use 0 and 1 for minutes. They use 0 and seconds, 60 seconds. Range for set is y such that. Remember, we move from the bottom to the top. So I'm starting at 0. I'm allowed to equal 0 for distance. And the highest distance I see is 100. And now you can go work on your assignment. You'll have plenty of word problems to practice.